Hello, hi, how are you? Happy Friday. Um, yeah, happy Friday to you. Um, let's get right to this. This we may have to put it as a back burner project. Actually, main dish project. Okay, we'll talk about some miscellaneous stuff like our appetizer stuff. Okay, so um, we'll talk about feedback loop. And we also talk before that. We'll talk about this anti-entropy, law of anti-entropy, right? Okay, law of entropy. Things tend to go like disarray, disorderly. That's law that governs object level. I'm gonna draw it. The seven echelons system. I gotta make sure you can see it. We're gonna talk about this guys later. You have what? God, angel, concepts, human, animal, plant, objects, right? That's the gachapo. How about that? Gachapo. Yeah, gachapo hierarchy, okay? Seven tiered metaphysical hierarchy, okay? Universal hierarchy. So, it's a universal hierarchy, seven tiered. Law of entropy, okay? Law of entropy governs object level. That's it. It doesn't govern anything else. Law of anti-entropy governs plants and animal and some people. Okay, so that's law of anti-entropy. Now, some humans, some concepts, some angels, actually, law of anti-entropy governs some concepts as well. Okay, even perhaps even some angels. But law of anti-entropy, that's a law of saints. Okay, that governs some good people, some good angels, some good God. That's law of sacrifice. That's it's not a descriptive law. It's prescriptive law. Prescriptive, and morality, ethics. What does it do? Yeah, just like Jesus, right? Right. If I have good stuff, I give it to the poor. If there are bad stuff, I take it in. Turn the right cheek, turn the left cheek. Oh, stop slapping my face. Yeah, that's law of anti-entropy. If there are bad stuff, it's like electron pump, negon pump, negative copion pump. If there are bad stuff, yeah, give it to me. If I have good stuff, I give it to others. Okay, so law of it's a prescriptive law. It's not descriptive law. It's a moral rules. Okay, so that's what distinguish some people from animals. They are becoming more like God, saint, law of saints. Okay, but it's not same as law of entropy though. Why? Because law of entropy, it becomes plus minus inside, and on the outside also plus and minus. Okay, things just become neutral. Law of anti-entropy, yeah, good stuff is inside of this organism. Bad stuff, it gets out. Law of say bad stuff, I'm gonna take it in. Good stuff, yeah, I give it to other people. That's law of like altruism. Here you have law of selfishism, egocentrism, that kind of stuff. Okay, there's more like animalistic kind of behavior. Okay, this law of saint, yeah, saintly, Jesus like, godly people. Okay, that's that. All right, it's that simple. Now, feedback loop, negative feedback, positive feedback. No, there's just one and only feedback loop. Okay, they don't know what they're talking about. Okay, there's only one and only feedback loop. Okay, it's things that either get worse or get better. Okay, but it's not exactly so. Yeah, I guess you can say if things go worse and worse, it's a negative feedback. Things get better and better, and positive feedback. Sure, yeah, you can say that. I mean, it's not too wrong to say that. Okay. But no matter what direction you may take in this feedback loop, um, it gets bigger and bigger in magnitude. Okay, is it -1, -2, -3, -4, or +1, +2, +3, +4? Okay, the magnitude increases no matter what the direction it may be, positive direction or negative direction. Okay, now the easiest way to see this feedback loop in human phenomena would be obesity. Okay, the obesity pandemic. Okay, people talk shit about nowadays. Oh, tobacco bad. Oh, alcohol bad. Nah, alcohol, tobacco, they're not that bad at all. Okay, it's the sugar and fat that is far worse. Alcohol, tobaccoism is less of two evil if you compare it to sugar fatism. Okay, sugar fat that's by far worse than alcohol, tobacco. Okay, so what happens is this. Okay, if you indulge, let's say, oh yeah, nowadays alcohol and tobacco is very stigmatized, right? So, but you gotta have some fun, right? Yeah. What else do you do? Yeah, sugar and fat instead of tobacco and alcohol. So what happens? You get obese. Okay. Now, as you get heavier because you're obese, you're fat. Okay. What happens is you become more inactive because you're too heavy to move around. Okay. You become more static, sedantic. Okay. And not only that, you become unhealthier too because your body is very inefficient. So you get sick a lot more often if you are obese. Okay. Not only that, you get injured more often too because you are heavier. Yeah, if you fall, yeah, you probably break a bone or two easily. You're just too heavy. Okay. So yeah, you get injured more often. Your body is very weak when you're obese. Okay. So, and also you're unattractive to the opposite gender and to people in general because you're obese. Okay. And not only that, you smell bad too because if you're obese, you cannot wash yourself very well. You cannot reach other body parts of yours because you're just too obese. Okay. So you smell bad, you look bad, so you feel bad, you're unhappy. So what do? You eat more sugar and more fat because you're so unhappy. Okay, and you get fatter, and it accelerates. So that's the feedback loop of obesity. Okay, the speed actually increases. So there is this acceleration, the speed of gaining weight, like how many 1 gram per day or 10 grams per day, you get fatter and fatter, but actually it accelerates. 1 gram per day today, then 20 grams per day tomorrow. Why? Because sugar and fat, it's like a drug. Okay, so you eat a certain amount of sugar and fat, you don't get satisfied with that amount, so you eat more sugar and more fat to get the same degree of satisfaction because your body, your brain, it get used to the previous dosage. That's how all this drug addiction, prescription drug addiction, like opioid, yeah, the doctor prescribed all these psychology based drugs. They are not illegal, but yeah, they're prescribed drugs. Okay, so doctors, they don't know what they're doing. Psychiatrists, okay, they don't know what they're doing. Okay, they're not quite guiding people to health at all. Okay, because they don't know. All these MDs from Harvard, Yale, they have no idea. Okay, they just make money. the more sick people in the world there are, yeah, the more money they make, because a lot of so many sick Americans because they are so obese, because they don't do any tobacco and alcohol. Yeah, they eat sugar, fat. Yeah, this drugs. Oh, they get sick all the time, and the increased demand for medical service, it drives up the price. So yeah, doctors get all the rich. Okay. So yeah, doctors probably there are some good doctors. I've seen them. Okay, but many doctors, they don't really care about morality. Okay, so what do they do? Whatever. Yeah, I make a lot of money, so right. I'm not sure doctors actually want to heal people or keep them sick, so that they come again and again, and so that they make a lot of money. Doctors, psychologists, psychiatrists. Okay, it's I mean, not all of them are bad. Okay, but many of them are, they don't know what they're doing. Okay, so yeah, look at Americans. They get bigger, bigger, fatter, fatter, obese, obese, and they get sicker and sicker. That's why medical cost is so high. And now the President Trump, look at him. He doesn't exercise. He's obese. Okay, and he's in charge of the country. Come on, vote for me in 2020 November. Okay, because I'm running. I'm official candidate. Okay, there's no one else who can fix this. I'm the only guy. I am your guy. I'm the only man. There is no one else who can fix this. Can I fix it? Yes, I can. Okay. All right. So, uh, because I will lead by example. Okay. Yeah, I exercise. I eat healthy. Okay. Yeah. Now, and I'm very smart too. Okay. Um. So it's feedback loop. Why? Because you are big, you're obese, you feel bad about yourself, you're unhappy, so you eat more to get rid of that unhappiness, and then you get even bigger, faster. Okay. So there's this acceleration in this speed of obesity. Okay. So it's like free falling motion, free falling body. It's like suicide. Okay. Because as you approach the ground, guess what? Your speed increases. Okay. Yeah, because there's this acceleration. Okay. Obesity is just like that. Okay. It's this temptation of sugar fatism. Okay. It's sweet. Okay. Yeah, it's like down slope, right? But you get heart disease, you get blood clogging in brain, in many parts of your body. You get polyps in your gut. You get back pain, knee pain, whatever. Okay, so because you're just too heavy. All right. You go to doctors all the time. It drives the medical cost, insurance premium for everybody. It just doesn't work. Okay, so President Trump, he doesn't know. All right, he has some knowledge about real estate, like real estate developing. He know how to build buildings, but that's irrelevant. If you're the president, you should be building a country. Okay, it's not as simple as building a building. I mean, building a building itself is not that simple task, but building a country, that's whole different level. Okay, it's not like, yeah, you can make some analogy. Okay, but President Trump, he's not capable of building a country. I am. Okay, I'm capable of building a brand new country and brand new generation. Okay, if you're the president, your job is to build a brand new generation. Okay, and like renaissance, rebirth. Okay, you have to be, in a sense, leader, a spiritual leader. Okay, all right. Okay. So, feedback loop. Yeah, that's about it. Yeah, we can get back to this, okay? And we'll approach this generalized audition theory, generalized operation theory. We're gonna approach this a very systematic manner, very consistent manner, because the way number system evolved is not quite consistent. Okay, we're gonna find some generic, consistent, repeating pattern. How operators evolve, and at the same time, how number system evolves. What's the relationship between the two? We're gonna approach this in a very, very consistent and logical uh, manner, systematic manner. Okay. After a break. Okay. So take five. All right. Okay. We'll be back. Yeah. Okay, it's kind of getting warm, so I'm gonna turn off the heater. Tomorrow I'm gonna attend a political meeting because they're gonna talk about some government financing. It's like 4 hours long, but I'd probably go because to me it's sort of like free class. So like government financing, budgeting. So yeah, it'll be a good class, free class. Yeah, I think I will go. Okay. So it's gonna be a long day, man. Because after that, there's another political event in a nice restaurant where I can drink. Yeah, it'll be a long day tomorrow. So after recording this, probably I will do some dancing. Yeah, because I need it. Okay, so all right, so let's get back to this. Okay, so yeah, I mean the way they came up with complex number system. Complex number is a very good invention, by the way. It gets extensively used. It's very useful system. Field theory, group theory, ring theory, they have limited application, like in quantum physics, whatnot. But quantum physics, eh, quantum mechanics, I'm not a huge fan. Okay, I don't think they have much practical contribution to engineering or betterment of humanity. String theory, whatever, or even relativity theory, it doesn't really have practical application. Not much. Okay, not very much. So yeah, but complex number system, yeah, it deals with imaginary number, right? But it has huge application in electronics, electrical engineering. Okay, so it's a good invention, complex numbers. But the way they jumped from real numbers to complex number, it's kind of icky. Okay, it's all more or less random, random. Okay, as we'll see next. Yeah, it's there are if you do mathematics, you may know this. I'm not sure, but I do know because I do a lot of mathematics. Okay, I'm an independent secular scholar. Okay, so there are different ways to generalize something. There are different way of generalization, different directions of generalization. Okay, you can generalize this way or that way or that way. Multiple direction of generalization. Okay. Okay. All right. All right. So in the beginning, we had natural numbers and addition. There was nothing else. Okay. So let's say x plus 1 is equal to 3. Okay? In the world of natural numbers, okay? Because things are supposed to just increase and increase and increase. You add something, yeah, it's supposed to increase. So what is x? 2, right? But in order to get that number 2, you have to introduce negative number or subtraction. So x is equal to, so you have plus 3 minus plus 1 or plus 3, okay, plus minus 1, okay? Because you're subtracting 1 here, minus 1 here, minus 1 here, okay? It goes to, that's how you kind of, you preserve the equality when you subtract the same number or add same number on both sides of an equation, okay? So shorthand, yeah, plus 1, go to the other side, it becomes minus 1, okay? But there's some anomaly here, okay? So in the beginning, when we didn't have the notion, the concept of a negative number, we only have operator that we call subtraction, which is inverse operation of addition. Okay? So 3 minus plus 3 minus plus 1 is equal to plus 2, right? Yeah. We don't have, as of yet, as of now, we don't have the concept of negative number yet. Okay? Then how do we discover negative number? It's this: x plus 1 is supposed to be bigger than x. So, and we are now in the we are so far in the realm of natural numbers. Okay? So we are assuming x is a positive number, 1 is a positive number, so x should be something bigger than 1 and bigger than x plus 1. It should be something bigger than x, bigger than 1. So x is, we are assuming x is a positive number, right? But as a joke, or some creativity, or some madness even, what about minus 2? I'm sorry. We don't have minus 2, okay? Let's say x plus 2, okay? So x is positive number, 2 is positive number, so it should be some positive number that's bigger than 2, bigger than x. But what if this becomes 1? Oh my goodness, that's so illegal, immoral even, that's crazy. Oh, we are doing addition, then how can this number even decrease less than 2? Oh, that's so blasphemous, sacrilegious. Oh, you cannot do that. Okay? It's like Einstein, right? Einstein said, oh yeah, hey, time is not absolute. Space is not absolute. Space can shrink, time can slow down. Time does not have constant speed. Speed of time is relative. Oh my goodness, no, that's something new, and that defies common sense. You cannot do that. So Einstein, in a way, kind of expanded our mindset, expanded the horizon, kind of. Science oftentimes is like that, okay? Mathematics, okay? Physics. Many times it's like that, okay? Yeah, so this is a discovery of negative number. 1 minus 2 is equal to minus 1, okay? It's no longer natural number, no, it's integer, okay? So that's the discovery of negative number, integer number system, okay? So now the next step, all right? Let's say we only have integers now, okay? Integers, and so we have plus, now we have minus, plus and minus, okay? Plus a plus b, this binary operator, because it's a function that takes in two independent variables, two inputs, one output. It can be expressed as plus, like f function a comma b, okay? Okay? Now, but plus is also unary operator too. Plus a is equal to plus a. Okay? Now, minus a comma b is equal to a minus b. It takes in two inputs and spits out one output. Okay? This is a function. Okay? Integer function. Alright? And minus can also can also be unary operator, unary function that takes in only one variable. Okay, minus of a, like f of a. Okay, is minus a. Okay, what is implied here? 0 plus a, 0 minus a. Okay, that's what's implied. What's 0? It's an identity element of plus operation and also minus operation. Okay, because a plus 0 is equal to a minus 0 is equal to a. Okay, so it's this identity component of this operator. Okay, so operator, this plus or minus, it always comes with an identity number. Okay, identity number of plus operation is 0. Identity number of subtraction operation is also 0. Okay, so, oh man, I'm getting cold again. Oh, it's the temperature pussy, dude. Oh. I'm so sensitive. I'm so sensitive. Let's see how my red wine is doing. Oh, it's good. I let it sit outside and it become like acidic. Oh, fantastic. I love that. Love that natural acidification by this. I don't know what does it. Bacteria, virus, fungus. I don't know. They do a fantastic job to acidify this dark chip red wine. Oh, it's so good. Good job, bacteria in my house, acidifying my cheap red wine and make it acidic so that I enjoy it. Fantastic job. Good job, bacteria. So, I'm gonna pour some more red wine. Oh shit! Oh, I broke my chair. Oh my goodness. Oh well. This chair is broken. I can fix it. I got nails and shit. Ah, what an idiot. I'll fix it later. Yeah, I can fix this. Ah. Some dirt chip chair from Walmart, man. Oh boy. That was stupid. That was very stupid of me. But it's better that this chair get broken when I was sitting, because if my guest was sitting on my chair and it gets broken, oh no, that's a lot worse. So yeah, it's better when it gets broken. If it gets broken when I'm sitting, so good. I don't get any guests anyway, but still, there's a possibility always. Okay, so. I fixed that stupid chair. Boy. Or maybe I'll just trash it. Buy a new chair. I don't. Whatever. Okay. Um. Yeah, that chair is already broken, so I don't think if I fix it with nails, probably it won't be a safe chair to sit on. So I may have to buy a new chair. I don't know. We'll see. We'll see. I have to make some structural assessment. Okay, this static vector, this distribution of weight vector. Okay. So the next step would be discovery of rational number. Okay, so multiplication is the next level. Why? Because you have a, right? A plus a plus a plus a blah blah blah. You do it n times, okay? And it becomes what? A multiplied by n. It's just shorthand, okay? This is sigma, which is just plus, okay? I is from 1 to n, a, okay? So it's a shorthand. It's a brand new notation. That's what multiplication is. Okay, it's just shorthand. Okay, how many a's are there? Oh yeah, there are 3 a's. Okay, we call it 3a. Okay, na 3a, 3 times a. Okay, it's a shortened notation. It's just like sigma. Okay, but if you're adding up the exact same number n times, we call it multiplication. Okay, it's an invention. Okay, it's not like this operator multiplication existed since Adam and Eve in the Garden of Eden. No, some other mathematicians later on, they had to invent this. Algebraists. Okay, it didn't exist in the monkey days or Adam and Eve days. No, they had to invent it. Okay, we take it granted because we learned it. But so we talked about macroscopic, this human history, how they discovered multiplication. Okay, they had to work for it. This macroscopic view, human history. Now, microscopically, let's talk about one individual. Me, for example, or you. When I was a child, like 5-year-old child or boy, I didn't know what multiplication is. I did not know. But I went to school, so I had to learn it. Just like ancient days, thousands of years ago, some algebraists had to invent it. Okay, me, yeah, I had to learn it. Before I learned algebra, this multiplication in elementary school, I did not know what multiplication is. Just like in the human history, before somebody invented multiplication operator function, nobody knew about multiplication. Okay, then this algebraist, he invented it and he started teaching other people, like some mad prophet. Okay, this dancing prophet, laughing prophet. I'm both. Okay, this dancing prophet, laughing prophet, crazy prophet. I'm all of those. What do you expect? I'm all alone and I got no date on Friday night, so. Okay, so that's multiplication, okay? A times n, okay? And because the next operation is a power operation, okay? Now, what? How about A multiplied by A multiplied by A, blah blah, multiplied by A, which is equal to multiply, which is pi. I is from 1 to n because there are n numbers that you are multiplying. We call this A to the nth, or in computer programming, A power n. Okay? All right. It's just notation, okay? So brand new operator. We define it in terms of a previous operator, okay? So in humanology, called mathematics, we call this plus as plus to the first. So, sorry. Oh, it's scary, isn't it? Plus is equal to plus to the first. Multiplication is equal to plus to the second. Now, power operation is plus to the third. Okay? And why limit ourselves? Okay? We can keep going. Like A to the A is, we can call it A top n, okay? Which is a plus to the fourth. Yeah, it can goes on and on and on and on. Okay? Okay? So now I'm getting hot. You know what? Why don't we take a break, okay? Oh, it's too hot. Let's take a deep breath because, yeah, this it's not too bad though, right? It's not a difficult concept per se. So we'll take a break anyway. Oh boy, hot. Oh, it's hot. Oh boy. I'm gonna take off this jacket, everyone. Whew. Hot, hot, hot. It's getting warm in Alaska. It's like what? Spring kind of. Snows, ice, they're melting. It's in 40s. Okay. So, inverse operation. Let's talk about inverse operation, okay? It's defined as this, okay? Yeah, we are just following along the line of this field theory, group theory, whatever, but we're kind of deviating. Okay, we take some good stuff from there, but we are not exactly following their line of reasoning. Field theory. Nah, yeah, you got some good stuff, we'll take that, but we're not going to follow all the way down this field theory path. Because I'm not a huge fan of field theory, okay? They tend to get more too complex, okay? And kind of elitist. No. We'll take good stuff from you, but we're not going to follow your path, okay? So, okay? All right, so you have A, right? A plus X. And what is the identity component of this plus operator? 0. Okay? Okay, we call it X is equal to minus A. Okay? We call minus A as inverse of A. So, inverse of A is minus A. Okay? And plus A's inverse we call it inverse is equal to okay, plus A's inverse is equal to inverse of this plus unary operator then times A, okay, which is plus of inverse of plus operator is minus, okay, so that's what it is, okay. Likewise, 1 is the identity element of both multiplication and also multiplication and division, okay, because well, let's think about this. Yeah, A multiplied by 1 is equal to A, right? What is, okay, let's find out what is identity element, identity number for multiplication operator. A times X is equal to A. What is X? 1, okay? How about A divided by X is equal to A? 1, right? 1, A over 1 is A, right? So yeah, both for the multiplication operator and division operator, the identity element is 1, okay? Now, how about inverses, okay? How about, okay, multiply by A, okay? What's the inverse of that? Is equal to multiply inverse operator, okay, A is equal to, yeah, division A, which is like 1 over A, okay? So that's the inverse of A in terms of multiplication. Okay? How about minus A? Okay, what is minus A? Minus. Okay? Yeah, plus. Okay? How about division? Division A is 1 over A, okay? Because minus A is equal to 0 minus A. What is 0? Identity number for the operator minus, okay? And what is division A? Yeah, 1 divided by A. Okay, because 1 is the identity number for the division, okay? Yeah. I'm sorry. Multiplication A is 1 times A, which is A, okay? So that's that, okay? All right. Because, you got it? Yeah, well, we are going quite fast because it's very elementary stuff, okay? We're just expressing easy stuff in more generic language. We're making easy stuff more difficult. Sometimes you have to do that if you want to generalize it to the nth dimension, okay? We are talking about dimensionality of operators. Okay, that's what we're talking about, okay? We're generalizing to the n dimension of operators, okay? Because yeah, A multiplied by X is equal to what? Yeah, identity component of multiplication is 1. What is X? Is equal to 1 over A. How about this? A divided by X, okay, is equal to 1. What is X? A, right? Which is equal to division A, which is equal to multiplied by multiplication A. Why? Because whenever you have unary operator, the identity number is implied before it. Okay? I told you we're gonna approach this generalization in a very systematic manner. Okay? Just like 0 minus A is minus A. Just like 0 plus A is plus A. Okay? That kind of stuff. By default, it's multiplication or plus. Okay? Yeah, it's like 0 or 1 binary kind of concept. Plus A or minus A. If it's plus A, we just call it nothing A, just A. 0. Okay? If it's minus A, then yeah, minus A. It's like 1. 0 or 1. On and off. It's binary. Boolean. Okay? Yeah, division, yeah, we specify division is like 1. Multiplication, yeah, we just call it nothing A, like 0. Okay, so yeah, there's some Boolean concept in here. Okay? All right. So far, the inverse operation for plus is minus. Inverse operation for multiplication is division. Why? Because plus and multiplication, plus and times, addition and multiplication happen to be commutative. The A plus B is equal to B plus A. It's abelian, okay? Commutative. A times B is equal to B times A. Yeah, it's abelian, commutative. Okay, ordering doesn't matter. And because of that, it's associative as well. A plus B, parenthesis, plus C is equal to A plus, parenthesis, B plus C. Okay, ordering doesn't matter. Just associative law and commutative law, commutativeness, associativeness, they're one of the same thing. Okay, for our purpose. Maybe you can come up with some creative, extraordinary, or crazy example where they're not exactly equal. Okay, but we're not getting into that. I don't know. I haven't thought about it. Yeah, but you are invited to. You are not crazy if you come up with that. You're a genius. Okay. Or you're a diligent person. Okay. Diligent student and also a teacher because you discover something new. Now it's your moral obligation that you teach others. So you're a diligent student and a teacher. You just got promoted because you found something new. Okay? You're a good person. Smart person. Okay. Oh boy. Man. So tomorrow I'm going to this long ass two political meetings back to back. So probably I wake up in the morning like what 6 o'clock, right? And I'll start drinking and do some recording and I will eat my breakfast after that. By then it'll be like 10 o'clock. Then maybe I'll take a nap from what, 10 to 12. I'll be sober enough to drive by then and some Saturday, dude. Oh boy. Not quite looking forward to it. Because Saturday I'm supposed to just rest, but tomorrow, yeah, I have to learn something new. Okay, this financial budgeting for government. It's like a free class, so I cannot skip that. Ah boy, but I'm not looking forward to it. Okay, whatever. Okay, so I'd rather have a date with a girl, but girls don't want to date me. Okay, that's the only reason. I'm a loser. Girls don't want me. Period. That's why I'm here. And tomorrow I'll be in political meetings. I'd rather have sex with a girl, but they don't want me. So why? Because I'm poor. Because girls they get attracted. They feel this horniness. They get turned on sexually when they see rich men. Okay, but I'm not rich, so they don't want me. Okay, yeah, there are all these ugly girls, obese, tattooed, pierced, but I don't want them because they're disgusting. Okay, in terms of sexuality, I have many female friends who are obese. Okay, but that's fine. Why? Because I'm not dating them. I'm not having sex with them. Okay, I have female friends who are tattooed, pierced, obese. That's fine. Why? Because they're not my girlfriends. They are just friends. So no problem. But when it comes to romance, I have to be sexually attracted to that lady. And if she's like tattooed and pierced and obese, then no, it's not gonna work. Okay. Oh well. And so yeah, if I go online dating, yeah, I'm sure there are some tattooed, pierced, obese ladies who'd go out with me, but I don't want to. And if a girl is tattoo free, piercing free, obesity free, then she don't want me because those are the girls who are the most attractive. So we guys are all the same, and girls are all the same. Girls want money. We guys want tattoo-free, piercing-free, slender woman. Okay, so yeah, those girls that I'm attracted to, piercing-free, tattoo-free, obesity-free girls. Yeah, they go to the highest bidder, the richest guy. I'm poor, so I never get the girl that I'm attracted to. And the girls who have a lot of tattoos, a lot of piercings, a lot of obesity, I don't want them. They're disgusting. I don't want to date them. Okay, so that's why I'm single. I have standard that's so high. I mean, higher than what I can afford. I want girls that I cannot afford. That's why I'm single. It's not like I chose to be single. No, I don't want to be single. Do I want to get married? No. Do I want to live with a girl that I'm attracted to? Yeah. Okay. But the girl I'm attracted to, they're higher than me. So they date guys with twice money, twice as much money as I make. So that's why I'm always single. Okay. Well, come on. I cannot change myself. I cannot date this tattooed, pierced, obese girls. No, I cannot get my penis stand. No, just can't do it. We take a break and we get back to this, okay? What am I talking about now? Oh boy, just taking a break. Ah, poor me, poor me. Okay, we are back. Oh boy. Ugh. So, I'm still debating internally. Should I buy a new chair or fix that chair? Because I guess it has only one screw. I can make it two screws each side instead of one on each side. So, but then it's already broke. So there's some bits and pieces. Maybe it's safer for my potential guests if I just buy a brand new chair. I don't know. I'm debating. Okay. We'll see. Okay. All right, let's go to the next stage. Okay, so uh, next we have addition, multiplication, and next step is power operation. Okay. So what is a to the x is equal to a? What is x? 1, right? Okay, so x is 1. Okay. So 1 goes here. Now I'm confused. Okay, so we have to find some inverse. Okay, so a plus x was 0. So x is equal to minus a. Okay. A times x is equal to 1 because 1 is the identity component of this multiplication operator. Okay. So x is 1 over a, division a. Okay. Now, how about a to the x, a power x is equal to 1. Why? Because 1 is the identity number for this power operation. Because, a power 1 is a, just like a times 1 is a plus 0 is a. Okay. Now, here you have x is equal to minus a. Here you have x is equal to what, division a. Okay. 1 over a. Okay. But here, what is x? Now it starts to be a little bit weird because x is logarithm base a to of 1. This is always equal to 0. It's a constant. Okay, so from here on it starts to be different. It starts to deviate from this plus and multiplication. But from here on, it's all the same though. Potentially. I haven't thought about this yet. Okay. It starts to behave very differently. Okay. And it's not only that, this power operation is not commutative. Okay, so a power x is not equal to x power a. Yeah, in some instances they are, but not generally. There are some instances where a power x is not equal to x power a. So it's not always commutative. Okay? Forget about associativeness. It's same as commutativity. Okay? So associativity is just extension of commutativity. Okay? So you're just switching the ordering. Okay? Commutativity deals with two numbers, associativity deals with three numbers. Okay? Alright. So we only need commutativity to think about. Okay? Oh boy. So in terms of inverse, okay? Inverse of this power operator, inverse of A is always 0. Okay? Here, inverse of A in terms of plus this addition operator is minus A. It depends on A. Inverse of A in terms of multiplication operator is a division A, like 1 divided by A. Okay? So it depends on A. But in power operation, inverse of A in terms of power operator, it does not depend on A. It does not depend on A at all. It's a constant function. It's always 0. Okay? But before we, let's take one step back. Okay? Let's take one step back and let's deal with division. Okay? Because there's some strange thing in the world of division. What is it? Yeah, 1 divided by 0. Okay? So division, so we had, in the beginning we had addition, then we introduced subtraction. Next step, we introduced multiplication and then division, right? And from here, we encounter some strange thing. Okay? What if you divide 1 by 0? Okay? If you divided 1 by 0, what is it? Yeah, it's positive infinity, right? Okay. There is also plus 0 and minus 0, okay? There's plus 0 and minus 0 in terms of like limit. LIM, limit. So we have to be very careful, okay? Where's my cranberry? Oh man, I need some drink because this is a heavy topic. Ah, I need some vodka. Oh boy. Let's say this 0 is true 0, not some limit approximation of 0, okay? Then yeah, it's positive infinity, okay? How about minus 1 over true 0? Yeah, it's minus infinity, okay? Okay? And now we are, Cantor, Georg Cantor, German mathematician who created set theory, okay? Or who was God's messenger of set theory, because prophet of set theory, because we don't like this concept of man being creator. No, God only creates. Man, we are just messengers, prophets. Okay. This infinity mathematics is something brand new. So okay, let's do this. All right. Let's say this division comes with some brand new expansion of number theory. I mean this number system. Okay. All right. You have now infinity mathematics. Also, you have infinitesimality. Well, infinitesimality it existed in the back in the uh, natural number. We had zero in the natural number system. Okay, so zero is not new to us. Zero is no stranger to us. But infinity is something new. This number system of infinity, it was introduced by this division operator. Okay. So as we add more and more operators, we are introducing more and more brand new number system. And infinity is the very first brand new addition to our number system. Okay. So infinity mathematics is like this. Okay. It's fascinating. It's very absorptive. It observes and it also collapses. You have infinity plus a is equal to infinity. Positive infinity is just infinity, okay? Just like number, plus a is a, right? Okay? And if we call this a is a positive number, okay? So a is a positive number, okay? So a multiplied by infinity multiplied by positive number. A is a positive number, okay? A is equal to infinity. It absorbs. It's something very cool. It's something very different. Something very brand new, man. Okay? Now, infinity plus or minus a is a positive number. It's infinity, okay? Infinity divided by positive a or multiplied positive a is also infinity. Okay. Again, we are doing. I have never seen anything like this in the mathematics books, textbooks. Okay. We are discovering something new, or maybe we are improving some pedagogy, instructional method, educational way of teaching mathematics. We are, at least we are improving education of mathematics. If we are not discovering anything new, that's still contribution. Okay, we are humble, like teachers, Nowadays, yeah, some teachers they unionize and some of them are arrogant, but we are like old school teachers. We are very humble. Okay, we are very altruistic. We want our students to be better than us, better than ourselves. Okay, that's humanology. Okay, we are very humble. We are very Christian kind of, yeah, humble spirits. Okay, all right. Yeah, humanology is like Christian or Islam, Muslim, Buddhist, Confucius, whatever, Lao Tzu, Zoroastrian, all the good religions out there. Okay, we are very humble. Okay, we are about bettering our children, next generation to be better than ourselves. Self-sacrificial, altruistic. Okay, you got the idea. Parental. Okay. So, infinity multiplied plus positive infinity multiplied by a, positive number a or divided by a is still infinity. Okay. Now, what about positive a minus positive infinity is minus infinity. Okay. minus infinity. Okay, so how about a divided by infinity? Positive number a divided by positive infinity. What is it? Do we need to take a break for this? Do we need to take a break for this? I think we do. Okay, so because I want you to think, I want you to be an active, independent thinker. Okay, because sometimes I'm wrong. Okay, I had to correct many of my errors. Because I'm only a human being. I make mistakes. Okay, so yeah, come on with this thing. Fill in the blank. What is this? Positive a is a positive number. This is a positive infinity. It's like Möbius stripe, whatever. Okay, goes on and on. Okay, positive, all positive. Okay, what is this? I mean, if you know mathematics, I'm sure you know what this is. It's trivial, but if you do not know mathematics, yeah, think about it. Okay, we take a break and I'll give you the answer. It's something very elementary. Okay, all right. Think about it. Okay. Okay, so we are dealing with infinity, okay? And Gary Cantor, he faced a lot of objections from very famous mathematicians like Poincaré. Poincaré, French mathematician, or also, I think it was Kronecker, okay? Kronecker, and also philosopher like Wittgenstein. He was kind of interested in language and linguistics. Yeah, he faced a lot of objections, okay, but he tried, okay, these transcendental numbers, whatever, transcendental set in his set theory, ordinality, cardinal numbers, ordinal numbers, okay, so, but some people like the theory, okay, so he got some advocates too. And he's a Christian guy, so he said, "Oh yeah, God told me to do this. Okay, I'm just a messenger. Don't kill the messenger, man." Gary Cantor, okay. So there's long history in this, okay. Infinity, all right. I mean, in limit calculation of limit of a function, we do this all the time, okay. So let's do it right this time, okay. So because it's very unexplored area, relatively speaking, okay. Because the objection was this, okay. If you have like 1 over 0, zero is like this. It's what? What, infinity maybe? Because 0 times 1 is 0. Now 0 times 2 is also equal to 0. Okay. Then now we have, if you pass this guy over, okay, 1 is equal to 0 over 0, and 2 is equal to 0 over 2, 0 over 0. What the hell is this? Okay. I mean, in Korean, actually, this is a pronounceable word. It's called 응, 응, like EUNG, 응. Okay. And 1 over 0 in Korean is a character, alphabetic character. It's H, Korean equivalent of H. Okay. Anyways, it's just some word play that I'm doing with Korean. Okay. Okay. Just as a side. All right. So, yeah, it's 1 over 0. Let's call it undefined. But no, it doesn't have to be undefined. Why? Because we can define it in a logical fashion. Okay. Because we love challenges. All right. Humanological mathematics. Yeah, we like challenges like this. Okay. And we are very good with logic, logical consistency. We are scrupulous, conscientious people. So yeah, we can tackle on difficult problems. That's what excites us, motivates us. Okay, so I will do that. Okay, no problem. We are humanologists. Okay, the chosen people, metaphysical Jews. Okay, we are chosen. Okay, chosen by God. Oh, metaphysical Islams, metaphysical Chinese, whatever, okay? Metaphysical Indians. Because metaphysical African Americans, even. Why? Because, oh, metaphysical Asians, metaphysical Indonesians, whatever. If you are chosen by God to do something, to achieve something great, yeah, you are African Americans, Indians who discovered zero, African Americans who discovered all this wonderful soul, jazz, music, or this break dancing, whatever dancing, okay? Yeah, we are all chosen for different purposes, okay? All right, let's continue. Trying to be politically correct, whatever. Yeah, we are all chosen for different purposes. It's not just political correctness, it's the truth. We all have different sets of talents, all different races, okay? Okay, uh, so we discover infinity, okay, it's a brand new number system, okay, out of division, okay. You have 1 divided by 0, oh my goodness, it's becoming infinity. Because positive 1, yeah, positive infinity. But if you divide minus 1 with true 0, yeah, it becomes negative infinity, okay? Now, what was the question I asked before the break? Oh yeah, okay. Plus 1 divided by infinity. Yeah, what is it? 0. True 0, okay? How about minus 1 divided by infinity? Positive infinity. It becomes 0, okay? Okay? True 0. Infinity is a different kind of breed. It's you have variable and you have constant, right? Infinity is halfway in between. It's like 0.5 constant or half variable. You have constant and variable halfway in between. There's infinity, okay? It's like mathematical philosophy or philosophical mathematics, no matter how you call it, okay? You have constant, a fixed number, a variable number. Infinity is kind of halfway between. I haven't seen anybody talking about this relationship between constant and variable and infinity. This tripartite, this 3 entities relation, and relationship of 3 entities: constant, infinity, and variable. Infinity is half constant and half variable, okay? So zero is a constant, all right? Yeah, it's a very special kind of constant, okay? Okay, just talking to my friends a little bit, okay? All right. Okay. So we just defined this brand new infinity number is a brand new addition, brand new number. It's not quite constant. It's not quite variable. It's kind of halfway in between. Okay. Special brand of number. All right. So Gary Cantor, whether he got it right or wrong, or half right, half wrong, I don't know because I just scratched the surface. Okay. So that's what infinity is as a number. It's not exactly constant, but not exactly variable because it's growing, getting bigger and bigger and bigger. Positive infinity. Going up and up and up, or negative infinity going down and down and down. It's just different direction, but magnitude is growing. So it's kind of like variable. But because we have this directional component, it could be growing or decreasing. Okay? Now, uh, this limit concept, okay. Um, all right. Positive infinity is shorthand, okay. Positive infinity is shorthand for limit x goes to positive infinity of x, okay. So it's growing up and like 1 2 3 4 5 6 7 8, it's going up and up and up and up, okay. And now we can define something that's kind of analogous to that, okay. We can define infinitesimality. Plus 0 is equal to limit x goes to positive x, positive 0 to x, okay. It's like 0 0.1, 0 0.001, 0 0.0001 is still approaching to this 0. It's not just that, it's plus 1 is equal to limit x goes to plus 1 x, okay. Minus 1, I mean, you, you can define 0 minus 1 as limit x is approaching 1 minus x. Wait. I got it wrong. Plus 1 minus 0, okay? X approaching plus 0, 1 minus x, okay? What is this? 0 0.9, 0 0.99, 0 0.999, 0 0.9999, okay? It's going toward 1, plus 1, but from the left, okay? And this guy can be defined as plus 1 plus 0, okay. Limit x approach to positive 0, 1 plus x, and it goes like this: 1.1, 1.01, 1.0001, 1.00001. It's approaching the number 1 from the right direction, okay. This guy 0 0.9, 0 0.99, 0 0.999, okay. It's approaching 1 from the left, okay. So that's the difference, okay. So we'll take a break, okay. Oh, so much to this. I'm getting cold. Okay. So we're back. You know, sometimes I do this static muscle exercise when I'm driving, waiting on this traffic light like this. Muscle flexing, you know. Oh, you know, I can flex every part of my muscle when I'm sitting behind the wheel, waiting for this traffic light. Oh, shoulder, forearm, biceps, my butt, thigh, my calf. My abs, you know. I feel better. Okay. Infinity versus infinitesimality, okay? So we have that. All from division concept, okay? So that's all we needed, all right? So yeah, that's the concept of infinity, infinitesimality, okay? Ah, boy, kind of getting tired. So yeah, 1 over 0, we don't have to leave it undefined. We can call it just infinity. Just like, oh, what is x squared is equal to minus 1. Yeah, we just define it as I, imaginary number, okay? Oh, what about 1 over 0? Yeah, it's just infinity, okay? 1 over 0 is infinity, okay? That's the definition of infinity, okay? Minus 1 over 0, yeah, minus infinity, okay? You're just multiplying minus 1 on each side. But, oh, how about, what if you have 1 over 0, you multiply minus 1 here? Then this becomes 1 over 0, which is equal to positive infinity. When you could have, because minus 1 is minus 1 over 1, minus 1 times 1 over 0, which is equal to minus infinity. Okay? So minus infinity is equal to positive infinity. Oh no, that's not right. Okay, so we just leave it undefined. Yeah, we got it. Okay, so that's why they left it as undefined, because we cannot equalize minus infinity to positive infinity, or can we? Okay, well, in a circular coordinate system, okay, we have circular coordinate system. You have one-dimensional coordinate system where you have positive infinity, minus infinity here, okay, and you just bend it. So you have plus infinity and minus infinity. This becomes the same thing. Yeah, we can do it that way. Okay, but mathematically, no, that's not very convenient way of thinking. Okay, so we do kind of understand. Okay, yeah, we do understand why they left it undefined, because it doesn't quite follow the convention of wisdom. All right. Well, but we don't have to give up because we can make another rule where when it comes to division by zero, okay, which is a big no-go in mathematics in your school, okay. But we can make a brand new rule where you multiply minus one upstairs or downstairs is no longer the same when zero is downstairs. Okay? Yeah, we can make a special rule. Okay? Then everything is fine. Okay? Alright. Okay. Yeah, we'll make a brand new rule where multiplying minus 1 downstairs, multiplying minus 1 upstairs is no longer the same when 0 is downstairs. Okay, so, okay. Then everything is fine. Okay. So yeah, infinity mathematics, okay. That's that. So a plus minus a divided by infinity plus minus infinity is always equal to 0. Okay? That's it. And a multiplied by plus minus infinity is equal to plus minus infinity, okay? And a plus minus infinity is equal to plus minus infinity. Okay? So we got it all. Okay? Yeah. This infinity mathematics is that simple. Okay? It's a brand new number. Alright? What is a? Non-negative number, okay? Yeah. Here, plus minus a, yeah, okay. Well, minus a times plus minus infinity becomes minus plus infinity. Okay? Okay. That's good. So that's infinity table, alright? Okay, let's move on. Oh, where are we? Yeah, a to the x is equal to a, then x is equal to 1. So how about a to the x is equal to 1, x is equal to 0. Okay, so inverse of well, but how about x? What would x be? X times x to the 8th is equal to 1. So here x is 0, right? Here a is 0. I mean, what is x? X is equal to 1. Okay, 0 or 1. So in terms of this power operator, you have two different kinds of identity numbers, okay, depending on the order. All right. That's why where it deviates, because a plus b is equal to b plus a times b is equal to b times a. Okay, but a power x is not equal to x power a, right? And what follows that is that this power operator have two identity numbers. In addition, plus, you have only one identity number, which is 0. In multiplication operator, identity number is 1, all right? And in plus, also is inverse operation, minus, subtraction, yeah, its identity number. The identity number of subtraction is also 0. The identity number of division is also 1, just like multiplication, okay? But when it comes to power operator, the identity number can be 1 or 0. It's kind of a boolean, okay? It could be 1 or 0, depending on the ordering. Is it x power a or a power x? Okay, identity is either 1 or 0. You have two. This power operator comes with two different identity numbers. It's 1 or 0. Okay? Yeah. So there will be then two inverses. Okay? Depending on the ordering, okay? Okay, so let's do that. A power x is equal to 1. A power x is equal to 0. X power a is equal to 1. X power a is equal to 0. Now let's think about this, okay? Here, what is x? X is equal to, so a to the x. So x is equal to a to the x. So x is equal to logarithm log a to the 1, which is 0. Okay, here a to the x is 0. Okay, so what is x? X is equal to logarithm of a to 0, which is equal to this is undefined. Okay, but yeah, it's undefined, then it is left to us to define it. Okay, so when mathematics teachers, textbooks, professors, they say it's undefined, it's like homework assignment for us, because it's for us to define it. Okay, nothing is left undefined in humanological mathematics. Okay, we define it if nobody has ever defined it. Okay, all right. If a is positive number, y is equal to a to the x, it goes like this, right? Y is equal to a to the x, okay? Y is equal to a to the x, okay? So this is actually x is equal to negative infinity. Negative infinity. Okay. That's what make this function to 0. So yeah, x is equal to positive infinity. No, negative infinity. Okay. Negative infinity. Okay. X to the a is 1. What is x? X to the 8th is 1. So x is equal to one, right? Yeah, x is equal to 1. Okay. Because x will be equal to this root a root 1, which is always 1. Because 1 to the what? 1 over 8th. Yeah, that's always 1. Okay, easy. Now here, x to the 8th is equal to 0. What is x? X is 0. Okay? Yeah. Why? Because x is equal to a root 0, which is always 0. So 0 to the 1 over a is always 0. Okay? Yeah. So we have that. So there are 4 different inverses. Well, 3 different inverses of this power operator. 3 different inverses of a in terms of this power operator. Okay, it could be 0, 1, or negative infinity. I have never seen anything like this before. Okay, we are exploring uncharted territory. We are like Magellan or Columbus. Yeah, we are visionaries, or some people call us crazy, but you know, we think what we are doing has some purpose, has a purpose. So we have compass, we have map, very primitive. We don't know much. We don't know much. Okay, we have map and compass, and we just start sailing. Okay, and we encounter all this strange land, just like Jacob. I became a stranger in a strange land. Okay. Yeah, we're just wandering around, kind of nomadic, travel here and there. Okay, we just discovered this. Inverse of this number a in terms of power operation, there are 3 different inverses: 0, 1, or negative infinity. That sounds very random, okay? Doesn't quite follow the pattern. Alright? And actually, if you think about it, what's the relationship between 0? I'm going to erase this, okay? Well, let's take a picture. It's kind of looks very strange. We'll take a picture and we erase it, okay? So, oh boy. Okay, we'll take a picture. Okay. Just using some different angle. Alright. Now we can erase all this. So the relationship between zero, division, and infinity, um, because let's say you have a divided by x is equal to 1, you know? So what is a? I mean, what is x? X is equal to a, right? X, okay. Now, x is equal to division a, right? Now, how about a divided by x is equal to 1? X is equal to multiply by a, right? Yeah. And what if a is 0? That's the question. Yeah, again, 0 is a very tricky number. 0 is a very special number. It took South Asia Indians to come up with this concept 0. 0 is a very special number. Okay, so we know. Let's go take one step back. Okay, so a plus x is equal to 0. Okay, what is x? X is minus a. Okay, how about a minus x is equal to 0? 0. Okay, what is x? X is equal to plus a, right? What if a is 0? Yeah, minus 0 is 0, plus 0 is 0. Okay, so minus 0 is equal to plus 0 is equal to 0, right? We have that. But it will start to differ a little bit. Okay, in plus, like summation, like addition and subtraction, yeah, minus 0 is equal to plus 0 is equal to 0, right? But in multiplication world, it's not like that. Okay, multiplied 0, I mean, division 0 is equal to what? 1 divided by 0 is equal to positive infinity. Okay, now plus 0 is equal to just 0. So I mean, sorry, here was this addition subtraction land. Now multiply by 0, to division 0 is 1 divided by 0 is positive infinity. Multiplication 0 is equal to 1 multiplied by 0 is equal to 0. So division 0 is not equal to multiplication 0, because division 0 is a positive infinity and multiplication 0 is just 0. Okay, so they are not equal. Okay, again, we are going back to the basics. We are doing brick by brick, sheet by sheet of papers, sheet of paper, whatever. We want to be thorough. Okay, we want to build a sound and honest and humble foundation of this mathematical generalization. Okay, that's what we are trying to do. Okay, Because field theory, this group theory, this ring theory, I think they cut too many corners. Okay, because they kind of cheated a little bit. Okay, so we don't want to follow that footstep of these field theorists. Okay, we are not quite satisfied with that. Okay, we want to do better. All right. So here I am in Alaska. I'm not mathematics major, or I don't even have a doctoral degree. I'm not PhD. Just some Alaskan aging Asian guy who's running for president. Okay. Now I'm defying these established mathematicians who went to MIT, who went to Harvard, who went to Yale, some University of Göttingen, whatever, Cambridge, Oxford, Yale, Stanford. I'm defying all them. I'm challenging them. Okay, because I don't think they did the good. They did the right thing. I don't think they did a good job. So I'm defying them. I'm not even PhD. I never majored in mathematics in any level. Okay. But yeah, there's a spirit of humanology. Okay, we challenge conventional wisdom. All right. In this sense, we are very liberal. Okay, we don't always follow old-fashioned tradition. Sometimes we rebel. We want some change. Okay, so humanology isn't exactly conservatism. It's not. It's very much liberalism too. Okay. All right. But that's what discovery invention is about. Something brand new. It's not about following what our parents, grandparents has done. It's not about just accepting what teachers teach us. No. It's coming up with something new, brand new, independent, about freedom, being liberal, liberty. Okay, so classical liberalism, it has very good components that conservatism lacks. Okay, that's why I have to be the president in 2021 January, because I can bring together left and the right. Okay, nobody else can do this except for me. All right, so you better vote for me in 2020 November. Okay, we'll take a break, and I will shut the fuck up and get back to mathematics. Okay, all right, take a break. Okay, that chair, I think I will just fix it rather than buying brand new one because I think it has enough surface area to have two by two. Okay. Two screws or two nails, probably screws. It's easier to put screws in than nailing. Yeah, I can make it very strong chair. I'll test it before I invite guests. Okay, so I can make it stronger. Okay. So I don't like waste. I mean, if I trash that broken chair, put it in a trash can, it go to waste. I'd rather just recycle that, just fix it instead of wasting, buying something new, wasting money to buy a brand new chair, to kill the trees, or I can just fix that broken chair and re- save my money and reduce waste in the landfill. Okay, so yeah, I walk the talk. You know, I'm very liberal in this sense. I'm very environment friendly, whatever. Okay, so we just discovered something new. Okay, in terms of this power operation, there are two different identity components. Okay, so a to the x is equal to a. What is x? X is equal to 1. Now, x to the a is equal to uh, a. What is x? Did I do something? Yeah, no. What would x be? Okay, x is equal to what? A root to a. Now we have an identity component that depends on a. No wonder no mathematicians tackle with this problem because it's very heavy loaded. It's a lot. Okay. Now we have some identity component that actually depends on what a is. Okay. Yeah, x is equal to a root a. Okay. Could be plus minus whatever. Oh boy, Alice's Wonderland, dude. In plus land, yeah, plus minus land, x is equal to 0. In multiplication division land, x is equal to 1. But in the power land, we have this identity component. Okay, it could be 1 or it could be a root a. Oh boy. Why? a root a power a is equal to a. Okay, so that's why it's an identity number in terms of this operation power that is not a constant, is a variable. 2 root 2 or 3 root 3, 4 root 4, 5 root 5. Okay, so identity is no longer constant, it's a variable. Okay, and there is this inverse, vice versa, reverse relationship. Okay, because when we talk about inverse of a number in plus minus land or multiplication division land, it always depended on that number. Okay, so a plus x plus minus x equal to a. X inverse of x plus and minus was always 0. Sorry. What is, I mean, inverse, okay. So now you have identity, okay, 0. X is equal to minus plus a, right? A multiplied division x was division multiplication, sorry, boy, I'm drunk. Identity component, which is constant. Okay, so x was division multiplication a. Okay, inverse always depended on what this number a is. The inverse of a depended on a. Okay, but in the power land, sometimes it's constant. Okay, because a power x. Okay, first of all, let's find the identity. Okay, a power x is equal to a. X is equal to 1. Okay, now what about a power x is equal to identity 1? Okay, what is x? X is equal to 0. Inversion of inverse number in terms of power operation of a does not depend on a. It's a constant. Okay, how about x power a is equal to 0? What is x? So x to the eighth is 1. Okay, so x is 0. No. X is equal to, what is x? 1? Yeah, x is 1. Okay? So x is equal to either 0 or 1, depending on this ordering. Okay? A to the x was 1, x is 0, x to the 8th is 1, x is 1. Okay, so the inverse of a in terms of this power operation, it does not depend on a. It's constant number. It's either 0 or 1. Okay? Yeah. But that's half of the story, all right? Because so inverse of a in this situation could be 0 or 1. It's not. It does not depend on a. That's kind of surprising. What if we swap the order? Okay, if x power a is equal to a. Okay, so in this situation, x is equal to. So we have x to the 8th is a. So x is equal to a root a. Okay, we ignore plus and minus sign for now. We'll put that in later. Okay. So a root a is that's the identity. Okay. Now next step, we need to find the inverse. Okay. First, a to the x is equal to identity a root a. Okay. Now, what is x? So we have a to the x is equal to a root a. X is equal to logarithm of a root a, which is equal to this a to the 1 over a, so 1 over a gets out. Logarithm of a to the a is 1. Okay? So yeah, it's 1 over a. Okay? Alright, so the inverse of a in terms of power operation is 1 over a. Okay? That's the first one. Now, second, x a. Okay? X to the 8th is equal to a root a. So what is x? I think x becomes like something like x is equal to a root a of a root a. What the hell is this? Okay, well. a to the 1 over a squared, okay? So I think that's what it is. Okay. Yeah. Strange looking thing. Which is equal to a to the minus 2. Okay. Strange looking thing, really. A to the minus second. Okay, so that's the other the force inverse of A in terms of power operation. So, well, we kind of thought that you will like 0, 1, and negative infinity. Okay, did we make any mistake there? I don't know. Okay, so such a rabbit hole. Why are we doing all this? I don't know. We're just bored. We're having fun. Okay, we just try to make a big shot, or we're just having fun in private, or yeah, we want to make a big name. I don't know. Okay, we continue this tomorrow. Okay, because I'm tired. I'm hungry. I'm starving. I need to eat. I want to. I don't think I can sing and dance because I'm just way too tired, hungry, exhausted. So we'll leave this for tomorrow, okay? And we'll get to the bottom of this, okay? It's very interesting theory, all right? So we continue this tomorrow, okay? All right. Good night.